In this video, we are going to talk about something called the power of a point. And in order to talk about this new topic, I want to use this example that deals with distance from a chord to illustrate and help us review some old topics while at the same time introducing something new. So let's complete this first example together in the video so you can see what power of a point is. So we're given circle A, so the center point is point A, and they ask us to find the length of the chord CD. So segment CD is a chord, and it's also given to us that segment CD is perpendicular to segment PQ. Now segment PQ is the diameter, since it's a chord that runs through the center of the circle. And because the chord and the diameter are perpendicular to one another, we know that the diameter actually bisects that chord. And that was from a theorem in a previous video. Now, they are asking us to find the length of chord CD. In order to do that, we're going to have to use some triangles. So first of all, looking at the diagram, I know that from point A to point Q, we have a radius length 10 inches long. So that means that from point A to point P should also be a radius 10 inches long. Now it says here that from point P to the intersection point M, that is 4 inches. And if I know from point P to point A is 10 inches, then I can figure that from point M to point A, this will be 6 inches. Because together 4 plus 6 gives me a radius of length 10. So A to P is 10 and A to Q is 10. And similarly, any other radius in this circle would be 10. Okay, so if I know that from M to A is 6, and then I know that if I connect A to D is also another radius. And remember, the radii inside of one circle never changes. So if the radii was 10 here, that means from A to D will also be 10. And I have a right triangle, and I can call M to D, I can call that X. So using Pythagorean theorem, I'll draw the triangle over here to the side, and I can figure out what X is. So X is here. We said this was 6 and the radius was 10. So using Pythagorean theorem, x squared, plus 6 squared gives us 10 squared. So x squared plus 36 equals 100. Subtracting 36 on both sides, we get x squared is 64. And square rooting, we get a final answer of x being 8. So that means that right here from M to D, which we called x, that is 8. So if M to D is 8, and that is congruent to segment CM, we know that from C to M is also going to be 8. Now let's go down to this box down below. They ask us for a few values. The first one they ask is, what's the value of segment CM? Well, we just said that that was 8. Then they ask, what's the value of MD, which we just also found was 8. And then they ask, what's their product? So product, remember, means multiplication. So if I take 8 and I multiply that by 8, I get 64. Now let's go over to this box. It's asking, what's the value of segment PM? From P to M, that was 4 inches. And then it asks for the value of M to Q. Now M to Q is this whole segment here. So M to A was 6 and A to Q is 10. So all together, 10 plus 6 gives me the value of MQ, which is going to be 16. And again, they're asking me what's their product. So if I take 4 and I multiply that by 16, I should get 64. So this is what power of a point tells us. this was not a coincidence. Power of a point says that whenever two chords or two segments intersect in a circle, that the length from one end of the chord to the intersection multiplied by the other end of the chord to the intersection will be the same in both intersecting chords. So let's summarize that in this box right here. The power of a point theorem says given two intersecting chords within a circle where point P is the intersection point, the product of the length from one end of a chord to the intersection point and the length of the other end of the chord to the intersection point is constant for any other chord that intersects point P. So this is called the power of point P. So basically what this is saying is if you take the length of segment AP and you multiply that with the length of segment PD, that will always equal the length of segment CP multiplied with segment PB. This always happens in a circle when two chords or two segments intersect within that circle. So now after you have the theorem written down on the front page, let's flip to the back and let's try some examples with some actual numbers. So number 1 says in the figure, segment CD is 24 centimeters. So that means that this whole segment is 24. They say that from C to P is 9, okay? And then they tell us that from F to P is 6. Well, if I know the whole segment of CD is 24 and from C to P is 9, then I can figure out what P to D is pretty easily just by taking 24 and subtracting 9, which is 15. So now I don't need to have this 24 written above. So now I know that from C to P is 9 centimeters, and I know from P to D is 15 centimeters. I also know that from F to P is 6 centimeters, and then they're asking, here's the big question, what is PG? So since we don't know what PG is, I'm going to call it X. Just call it a variable since I don't know what it is. So using my power of a point theorem, I know that when I multiply the two chords where they intersect, they should be equal to one another. So the setup is going to be as follows. I know that from C to P times from P to D will equal from F to P times P to G. So writing that out looks like this. C to P times P to D is equal to from F to P times P to G. So once you get a hang of this theorem, you won't have to write that out every time, but I'm going to write that just because this is our first example. So from C to P, that was 9, and I'm going to multiply that with P to D, which is 15, and that's going to be equal to F to P, which is 6, times P to G, which we don't know, which we used X to represent that length. So 15 times 9, that gives us 135, and that is still equal to 6x. And then dividing both sides by 6, I get that x is 22.5. Now, since x represented PG, that means that segment PG is 22.5 centimeters long, and that would be our final answer. Let's move on to number 2. So number 2, this should start to come a lot quicker. We have two segments or two chords that are intersecting within our circle. So we can use power of a point theorem to find the value of x. So the setup will be as follows. 4 times x will equal 5 times 8. So 4x is equal to 40. Dividing both sides by 4, I get that x equals 10. In our next example, I'm going to have 16 times 9 is equal to x times x. So 16 times 9 is 144. X times x is x squared. And to get x by itself, to undo a square, use square root. And x is going to be 12. So hopefully at this point you've kind of gotten the hang of how to find values of x using the power of a point theorem. Try number 3 on your own. Hit pause on this video, and after you've tried the problem, go ahead and hit play again so that the answer or the solution will pop up and you can check your work with what my answer is. So at this moment, press pause, and I want you to do number 3. Okay, so by now you should have tried number 3, and you can take a look at my work. After setting up the power of a point equation, you should have gotten that x was 5. But remember, x only represents the distance from P to A, and the question asked you to find the length of segment DA. So DA is the entire chord. So once you found PA, which should have been 5, you should have added that to DP, which was 4, giving you a total length of segment DA to equal 9. This concludes the video on power of a point.